Why is that divided by that?
Oh, because that's the way the cookie crumbles. I have to wait for it to restart so I can explain. So give me 1 second. Try to reconnect over here. So by chain rule, the derivative of ln of f of x is f prime of x divided by f of x. Right? So you have the whole thing over here to be f of x. So the derivative of it is a product rule, goes on top, and the function itself goes on the bottom.
That's for the log.
ln, yes. Now we can kick out 3x e to the x minus 1. And what's left in parentheses is x plus 2 divided by 3x squared e to the x minus 1. And now you notice that e is canceled, 3 is canceled, and one of the x's is canceled. And the whole problem is now x plus 2 over x. Cool beans, huh?
How do you get the, how is it over x if they all cancel out?
Great. Now, to show that this works, we can use some algebra before we differentiate. So if I have ln of 3x squared e to the x minus 1, we can use algebra here to separate this, because we know, maybe, that the formula of ln of xy is ln x plus ln y. Hopefully we know that formula. Since you have two multiplications, you can split this into ln of 3 plus ln of x squared plus ln of x minus 1. And just one more simplification is ln 3 plus 2 ln x plus ln of x minus 1. So the 2 as the exponent jumps in front using the formula ln x to the p is p ln x. Those are some of the basic formulas from your pre-calc. So now when you take the derivative of a constant is 0 plus 2 times 1 over x plus x minus 1, the derivative on top is just 1. And when you put this together, you have 2 over x plus 1 over x minus 1. Find the common denominator of x minus 1. That's 2x minus 2 plus x. Something is terribly wrong, I think. 2x minus 2 plus x. And we get 3x minus 2 over x minus, I don't like this. What's wrong?
ln e to the x minus 1.
Oh, I forgot the e. Yes, thank you. I forgot e. X to the minus 1. So now ln and e cancel, and this term is just x minus 1. So this term is just x minus 1, which means that this term is x minus 1, which means that this is no bueno. There we go.
Why x minus 1? It is supposed to be just 1. If you take the derivative of x minus 1 is 1.
Well, that too. So the derivative of x is 1, the derivative of minus 1 is 0. Yes. So now 2 over x plus x over x is x plus 2 over x. Yes, good. There we go. So we did the algebraic transformation where we took the original problem, used the properties of logs to break the problem down into three separate terms, because we have multiplication, 1, 2, 3 factors here. They turn into 3 terms. ln cancels e over here, so you just get x minus 1 when you hit with the derivative. ln3 is a constant, is a number, so the derivative of that is 0. Derivative of ln x is 1 over x, you have a constant times 2, so that's 2 over x. And then derivative of x is 1, derivative of negative 1 is 0, so we don't need it. And now you do the common denominator, and you get the same answer as before. This problem, what we did here, logs are really nice because, as you can see, they can help a lot with product rule and chain rule in terms of avoiding them, actually. If you don't have logs, you have to grind through everything. The chain rule strikes back. Let's see. Can't use trig yet because we didn't cover trig yet. So I have to stay with polynomials, exponential. Ah! The derivative of e to the 3x divided by the square root of x squared plus 1. Think about that one. So what is the main rule?
Quotient rule?
Quotient rule.
Can you do as a product to make it easier?
Ooh, you want the product rule. Spicy. How are you going to do the product rule?
X squared minus 1 everything to the minus 1 half.
That guy right there, Nicholas. So, this is officially where you retire quotient rule forever, right? Because the problem can be rewritten as e to the 3x times x squared plus 1 to the negative 1 half. And now you have a product rule with a chain on the second one. Let's go. Copy the first times the derivative of the second. That's going to be negative 1 half x squared plus 1 to the negative 3 half, because you have to subtract 1, times the derivative of the inside, which is 2x. That's where the chain rule kicks in. So this part over here is the chain. Then you have plus, copy the second one as is, times the derivative of the first, which is 3e to the 3x. Now, we write, well, first off, we can cancel the half and the 2. So we have negative e to the 3x divided by x squared plus 1 raised to the 3 halves, plus 3e to the 3x divided by x squared plus 1 to the 1 half. Now, in order for us to have a common denominator, we are going to multiply the second one with x squared plus 1, because that will give us 3 halves in denominator. So x squared plus 1 to the 3 halves. And then we have negative e to the 3x plus 3e to the 3x times x squared plus 1. And we can factor out e to the 3x, which leaves us, copy the denominator, 3 halves, which leaves us in the numerator with 3x squared plus 3 minus 1, so plus 2. And that's it. And if you used quotient rule, you should be able to get the same answer once you simplify. Now this problem is ready to be set to 0. And then find potential values here and go from there. d dt, so this one is in respect to time, of I was about to put x. T squared plus 6t minus 1 divided by e to the 2t plus 6. So we have a quotient rule again, and the chain rule. Let's do quotient rule just because we can, but you can also write e right to the negative 2t plus 6 and do the product again. So copy the denominator, square it, and then copy the denominator as is, times the derivative of the top, which is 2t plus 6, minus, copy the top, that's t squared plus 6t minus 1, times the derivative of the bottom, which is e to the 2t plus 6 times 2, and that's your chain. So I hope you see that e can be factored out. So when you factor out, you will be able to cancel the square. And what you are left with is 2t plus 6 minus t squared minus 12. Minus 2t squared minus 12t plus 1 over e to the 2t plus 6. And now common terms, so that's going to be negative 2t squared negative 10t plus 7 divided by e 2t plus 6. Ta-da! Cool, right? Technically, you can do this, but then in chapter 4, I'm going to teach you something that you are going to look at this and just tell me the derivative without doing any work, which will obviously make everything we just learned so far a joke, but it's coming up. Cool? Of course, math. But that's going to be in chapter 4. Now, you can go home and spend time, because clearly you have a quotient rule with a product here and then 3 chain rules. I mean, you know.
That's nothing, right?
Yeah, nothing you can take care of in an hour or so. But in chapter 4, we're going to make a joke out of everything we did so far and make it easy. And, you know, a problem like this, you're just going to, you know, write down the solution and say, oh, okay, yeah, not a problem. Not a problem. So we'll get there eventually. Should we do another one?
Yeah.
All right. So what should we do? How about you make a problem up? Hmm? 1 plus 1 is 2? Okay.
12.
1 plus 1 is 12.
It's actually 11. Oh.
Yes, when you put 1 and you put another 1, it's 11, exactly. So, is there a good chain rule problem that we could work on? course, there is a good chain rule problem that we could work on. You can't just, yeah, you just can't think. Ready? I'll see you on Thursday.
That's a 3-pointer though.
Yeah. I need the rubber band because this is not working. Yeah. Thank you. Nice. There we
What are
go.
you doing too strong?
What do you? It's too strong.
The roof
Zach.
is too low.
The ceiling is too low. It's 10 feet ceiling. What do you mean it's too low?
It is too low.
Everything is too low for you. Spicy? Spicy, I know. How many functions do we have? Nope.
Let's say four.
Four. And then that 3 gets kicked out as a constant. We don't have to worry about it. So we have 4 functions. Any specific rules that we want to worry about or no?
Product rule.
Nope. No product rule. We have 4 chain rules. You see, sine will have the argument of something, and that something is this whole thing here. So this is not sine times e, because e is within the sine. Make sense? Have you ever seen this identity?
Does not look familiar.
Can anyone figure it out? What? Nice, very good. Cancel out the n, exactly. If you cancel out the n, you get 6 equals 6. It's identity. It's a trig identity. Yeah, write this one down. It's useful.
Will be on the test.
Yeah, put this one on the test, okay? So, yeah, none of that stuff, please. Trigonometric function has to be followed by the argument, just like square root has to have something inside. ln has to have something inside. So, this is the argument of sine. I can rewrite this kick 3 outside, and I can open the parenthesis and say sine of e to the x squared plus 1, everything to the 4th power, if it helps. Because, I'll write this in blood, sine to the, let's say, p of x is the same as sine x everything to the p. So that 4th power goes outside to everything, and you see that sine has to have some argument here, right? And that's all of this. All right, so now we have chain rule 3 times. The first thing we have is x raised to the 4th power. Do we all agree? X raised to the 4. So that's going to be 4x to the 3. Are we good with that? Now that x is sine e to the x squared plus 1. Now we dig one step in. And when I dig one step in, the next derivative I have to take is derivative of sine, which is cosine of x squared plus 1. Then I have to dig one more in, and that's the derivative of e, which is e to the x squared plus 1. And finally, the derivative of the exponent. So we have chain, we have chain, we have chain. There we go. Good one. So, how many functions? 1, 2, 3, 4. How many in the answer? 1, 2, 3, 4. All I need to do now is to push all of this on the pile. 3 times 4 times 2 is 24. So 24x. then write E, then write sine cubed E, and then times cosine E. Another one? Of course, you love this stuff. Let's chill a little bit, because we did some spicy examples. So, ddy of secant square y. The network keeps dying. All right, so we can rewrite this as secant y squared, which will be 2, and then we have secant y, and then the derivative of secant y is y tangent y, for a total of 2 secant squared y tangent y. Now here's the challenge. Same question. D dy convert into 1 plus tangent squared y, and then get the same answer.
Do you want us to do the derivative of tangent? Do you want us to use the identity?
I use the identity. Secant squared is 1 plus tangent squared. So I already used the identity. You just need to take the derivative. Oh, this is called mathematical witchcraft.
It takes about 2 weeks to get used to it. It's like stuff.
3 days.
Don't you get those people? I have a lot of people on that chair. Those could you trust on? No, I don't. Like, the way you
Yeah, you gotta do it. You know, you're not supposed to use left. What's wrong with your left?
What is it?
Oh,
No, I use it. Like, when I'm using my hand. One of those, like, what the barbie use. So, I don't think those. Make sure you clean it too, because if you don't like clean it up, yeah, it breaks out. So,
Maybe your grain is upside down.
inside out.
yeah.
I'm so lazy, so I just
Gosh.
whatever it is.
My hair was
No, it's, I'm too lazy.
Yeah.
Just like
Just never go like this. That's
with the Can you imagine using all those things that my grandfather used?
The straight razor?
Yeah, like those are freaky, man.
Those are
that's
really
scary. I can't.
I did.
Oh, I'm too
Use the Rambo knife. You've seen the movie. All right, guys. It's time to solve this problem using the identity. Derivative of 1 is 0. Plus the derivative of tangent squared is going to be 2 tangent y. And now the derivative of tangent is secant squared y. And it's the same answer. Cool, huh? The derivative of secant squared and the derivative of tangent squared give you the same answer. Right? I said you had the prescription. There we go. Want to try these? Right. Let's do one more trig and call it quits. The derivative what rule? Okay. So if we use quotient rule, we will have tangent squared 3x, tangent 3x times the derivative of sine is 3 cosine 3x minus sine 3x, and the derivative of tangent is 3 secant squared 3x. Good. Now, is it clear that this cancels all into the secant 3x, tangent 3x with the 3's floating about, or no? All right, let's keep using the sledgehammer. So we have 3. Tangent is sine 3x over cosine 3x times the cosine of 3x, and they cancel, minus And over here we have sine 3x 3 sine 3x, and then you have the secant squared 3x over, well, it's tangent squared 3x. So we can kick 3 outside. Oh, sorry, 3 sine x. So kick 3 sine 3x outside. And what you are left with is 1 minus secant squared 3x divided by tangent squared 3x. Yes? Nice. That definitely works. What I'm going to do is I'm going to swap the spots here and factor out the minus using the algebra formula, which says that if you want to swap a minus b, you can kick the minus outside and it becomes b minus a. So if I kick a negative outside, it becomes secant squared 3x minus 1. And what's that equal to? That's equal to tangent squared. Very good. So this thing now is tangent squared 3x, which is why they cancel. And the answer works out to be negative 3 sine 3x. What happened? Yes. If you know identities, these things become much easier. So the derivative of sine 3x over 1 divided by sine 3x over cosine 3x is equal to, these guys cancel, the derivative of cosine 3x, which is negative 3 sine 3x. So much better than pulling a rabbit out of a hat. I can't tell. Like when you get some of these trig identities. So we caught up with trig, right? Good. Section 3.10, derivative of inverse trig functions. So we are left with implicit differentiation, related rates, something else, and so we have 4 sections left to deal with. There's one more section, can't remember which one. So 4 sections left. Oh, I think logarithmic. Yeah, logarithmic. Cool. So we have 4 sections left in this chapter, and then test 2. 4 sections. And the labs 2 and 3 are the material for the next exam. Bye.